Yeah, I don't have a ton of time right now. We should probably
Okay.
get done.
Yeah, it's all right. I don't really have a lot of time either.
Yeah, if we have to, we can just like tackle, see if anyone had any questions, tackle the quiz. I mean, the quiz, it doesn't look too bad. But I know it's a Saturday and kind of busy.
Yeah.
Okay.
Yeah, the quiz definitely doesn't look bad at all.
Okay. No, get off the stairs. Thank you. Sorry. Okay. Oh, we should probably start with the prayer. That's what I'm forgetting.
Yeah.
I guess I can go ahead and say it this time.
Okay.
Dear Heavenly Father, we thank Thee for this day, and we thank Thee for this opportunity we have to be able to work on our math class and to be able to learn and gain from Thee, to be able to complete this quiz. And we thank Thee for the time we've had to study, and these things we ask or say in the name of Thy Son, Jesus Christ. Amen.
Amen. Hold on. Yeah. Okay. So I had a question. I don't know. It might just be a silly thing. Whenever whenever it's like find all the values within this range or whatnot, and let's say it gives you sine, is it just always, does sine use 2k pi and cosine just uses k pi? Or does that change for whichever function you're using? Or I don't know. I just couldn't figure out.
It just depends on like the angle you have, or the like angles. So like say, I don't know. So here, let's say we have the cosine, for example, of pi over 3 and 5 pi over 3 down here.
Okay.
So these two angles are, I don't know how to explain this. Basically, this angle right here you can get by having pi over 3 or pi over 3 plus 2 pi, and then k, which is just however many times you want to go around. So it'd be like 1, k is 1, k is 2, and it's always going to be that angle. And same with this angle down here. But if you just add pi to it, then it just goes to that, which is 2 pi over 3. So these two angles, where did it go? Right here. I lost my train of thought. But yeah, basically that's what the 2 pi or whatever thing is. But if you have like, what would be a good example? You have sign.
Yeah, I mean that makes a little more sense. Yeah, because I was trying to figure out if it was, you know, every time you signed it had to be 2k pi, but I was like, I was trying to figure out what exactly determined that value, but that makes sense depending on what triangle you're making.
Yeah. I was just trying to find another example.
Why are you chewing on my pens?
But I don't. No other example really comes to mind right now. But I hope that made a little more sense. Yeah, I don't know.
Yeah, that I think I see what you're coming at. I might work a couple more practice problems and go back and make sure that I'm getting that. Yes. Okay. Well, since y'all don't have too much time, do y'all just want to jump on the quiz and kind of work backwards? Like
Yeah.
go through the quiz. If we have a question, maybe jump to that section or
yeah, let's do that.
Yeah, that's probably a good idea.
Okay. Can I have my paper? Sorry, it's me and my son here today, so he wants to be a part of it.
Teach them while they're young.
Okay. Okay, so we have to match each expression with an equivalent expression.
And that's super easy. Sine of x equals.
Well, that's E.
Yeah.
Do you think she wants us to like work out like the identities make this equal, therefore it's C? Or...
It just says match. It doesn't say like show your work.
Yeah, because I mean, I can look and say, hey, that's fine.
Yeah. But C equals that first one because of odd and even identities.
Even odd identities.
And then sine of x minus sine of y equals 2 cosine of 5 plus sine of 1 because of sum of product identities.
Sorry, what'd you say?
Sum to product identities. That second one is A.
Cosine squared minus cosine minus sine. Hey, don't draw on the table, on the paper. Cosine sine. Yeah, these are my papers. Cosine would that one, the third one, be E? Hold on. No, wait.
No, it's B. That's a double angle identity.
Oh, okay, cosine 2x. Okay.
And then number 4 is going to be D.
And is that the sum to product too?
That is...
Yeah, I think that one's cosine minus cosine is sum to product. So that'd be 2 sine.
Oh, yeah. Negative 2 sine, blah, blah, blah. Yeah, that's sum to product. And then the last one is E, cosine squared of 3.
Hey, don't draw on Daddy's computer. Here. Okay. Awesome. Yeah. Okay, proof of the product identities.
Given to you.
Okay, so show the proof for the product identities. Can't even talk today. The proof of the first product to sum identity is given to you in the e-text. The proofs for the other 3 identities can be found using similar techniques. Show the proof for one of the other 3 identities in the space below. So, sum to product. Okay, so work out the identities for one of those.
He's asking to find a problem in the e-text? Or am I just way confused?
That's kind of what it sounds like.
Yeah, because it shows you how to do the it shows you how the first one works out. But like, is it wanting us to just do an identity of the other ones? Or does it want us to have values in them? Does anyone happen to know where the text has it?
I'm pulling it up. Let me look.
Product to sum. Yeah. What are you talking to, little baby? Of course, my e-text signs out of itself. So, hey, no, that's my chart. Oh. Where's your paper go? Come on. Here. Here. Go right there. Product to sum, is that what we're looking for? Product to sum identities.
Proof of first, product to sum identities is given to you in the e-text. Okay. Proof for the other 3 identities can be found using similar techniques. Show the proof for one of the other 3 identities in this space below.
Sign of, okay, yeah. So it gives on page 459 of the book, it gives us the whole sine and cosine identities. So I guess it wants us to just work that out with one of these different ones, like yeah, so the proofs for the other 3 identities can be found using similar techniques. Show the proof for one of the other 3 identities. Okay,
Wait.
any one of those sound better than the other? Here. Hey, where'd my pencil go?
The proof.
Yeah.
What's in the yellow?
Huh?
What's in the?
Oh,
Is that what it's asking? Like,
if you right above the yellow box, right where it says the big bold word where it's product to sum identities, it works you through how to get one of the identities, but because so it adds two of the identities together to get the product to sum.
oh, that makes sense now. Oh, okay.
Okay, so it puts two together to get the last one. Hey, where'd my eraser go?
So we could add cosine A plus B plus cosine A minus B together.
Okay, yeah, let's do those.
Yeah, okay. Oh. There we go.
I think I got it worked out. I mean, I essentially just did the same steps that they did, but with cosine.
That's all we have to do, I think.
Yeah, because then that would give us the product to sum cosine A, cosine B equals half of cosine A minus B plus cosine A plus B. So did you just work it like I did I did the cosine. Let me back up. Got the sine A, sine B canceled out. And then I did 2 cosine A, cosine B, divided that by 2, and then got the cosine.
Yep.
Yeah.
Okay, well, that's not too
enough. Yeah. Okay, number 3, find all angles of a in 0, 2 pi that satisfy the equation sine 2a equals tangent a.
Hey. Do not pull that, okay? Yeah, it's gonna snap and hurt you. Okay. That's the tablet. Why do you have the tablet? It's gonna be Giovanni, leave the cat alone. Let her go to sleep.
Having luck with this one.
Not really.
Yeah, like so. I guess I'm initially confused with just what we're finding. Are we finding where tangents equal the sine of 2a? Because I thought I had two solutions, but...
What do you... Let me see. What do you have?
Well, I had the pi over 4, 5 pi over 4, but it's the like I don't think my thinking process is correct. Or I guess n pi over 2. Those would be places where tangents equal to 1. But I guess I'm just not sure. Are we trying to find each place where like in the circle, each place that tangent is? I guess I'm just not sure what we're looking for. It's equal to tangent. Yeah, because like all the examples I've seen in work, like in the textbook, it's got sine of 2 alpha being equal to a value. But since I don't really know what value tangent itself has, and I'm not really sure where to plug that in other than 1.
Mm. What did you have, Ariel?
Well, the only one
How did you start?
well, like I said, I don't think I'm going about it the right way because since I'm not sure what, like I said, what exactly I feel that I'm doing, I ended up getting pi over 4 and 5 pi over 4 because I took that as the ones that made tangent equal to 1. And I ended up doing that, I don't know, because I was trying to find a way, I don't know, like, I don't think I was thinking the right thought process. Because I was trying to set tangent equal to 2 alpha, and if tangent of alpha, like if they were equal to each other, so then it would have to be something that made it, but I guess that doesn't really make any sense now that I think about it. Because then tangent would have to be 2, no? Would it have to? Oh, it would have to be a half. Yeah, tangent would. Never mind. Get off the couch, please. Yeah. Do y'all have any other ways y'all were trying to go about it? I think still confused me a bit.
I'm not really getting it 100%.
Yeah, like I said, I'm just confused because all the 2 alpha signs that I've worked from the book and stuff have values. And since tangent isn't like a value in itself, I'm not 100% sure what we're doing with it, I guess. Is there like maybe a different identity that we could change it into? Hey, get off of the couch, mister. Yeah. Yeah, I'm gonna get you off of that couch.
Well, tangent equals sine over cosine.
Yes.
Wondering if that had something to do with it, but now that I'm looking at it, I can't really figure a way.
Yeah, see, that's what I was thinking, but then it was like, yeah, find all the angles that satisfy that. And I'm gonna go, wouldn't they all satisfy sine over cosine?
Can I see like your work for this problem?
Well, I mean, like I said, I don't think it, because I was trying to set it to 1, but the only reason I was trying to set it to 1 was because I was trying to set sine of 2 alpha equal to tangent of alpha, which I figured 1 was the easiest way to go about that. And then, so all I did was find the ones that went to 1 with sine and cosine, which was the square root of 2 over 2 over square root of 2 over 2. And that's pretty much all I was trying to think of something there, but there's no way for 2a to equal a. Yeah, I was trying to make those equal to each other, but I don't think that makes any sense.
Okay. I think my problem is the fact that sine is 2a and tangent is a.
Uh-huh.
But then, wait a minute.
Makes me almost wish it was a typo or something.
Oh, wait a minute.
Yeah, because all of the examples that I'm going through in the text are all giving some kind of like sine of 2a is 1 over square root of 3 or something. So so I get that they're solving for those particular angles, but I'm like, tangent of alpha, what? I don't know.
I don't know either.
What if we gave it a variable? No, that doesn't make any sense. What?
Oh.
I don't think this really helps anything, but I set sine of 2 alpha equal to tangent of alpha and got alpha equals secant over 2, but I'm don't even know if that really. I was trying to rewrite it in a different way to try and get something else, but hey. Hey. Go color your Paw Patrol. So, sine of 2 alpha would equal tangent. Trying to find somewhere where tangent is double sine, like I don't know. 2. Yeah, I'm a little stumped on that one.
I don't know, all the alphas and stuff just usually confuse me.
Yeah, same here. I'm good to a point.
Honestly, all this sine and cosine stuff confuses me most of the time too, but I've sort of gotten better at it. Until you throw in the alphas, and then it's just like, I don't know what the heck's going on anymore.
Yeah.
But I've actually got to go.
Oh, okay.
I've ran out of time. But I'll see you guys next week.
See you.
Okay, see ya.
See you guys.
Hey, what are you doing back here? Okay, you can play with that. Do you want to try to move on to 4 and maybe come back?
I already solved 4.
Oh, well, there you go. Oh, here, let me try and work it out. Just double check.
Okay.
Would that one be the sum to product identities?
Yeah.
Or I guess
Yeah.
probably.
It's really straightforward. You just like plug things in.
Okay, and then yeah, that's what I was thinking. I glanced at it, I got it down, but I didn't actually work through it. Where'd you take all my stuff? Hey, Giovanni, where'd you put all my stuff?
I thought I had a lead on this third problem, but I've come to another dead end.
Oh. Giovanni.
Yeah.
Oh, wait a minute.
You onto something?
I think so.
Hey, Giovanni, where'd you put my calculator? Can I have it back, please? No, that's the cat. I need the calculator. He's pointing to the cat on the floor, and I don't know what he did at the calculator.
That's funny. Okay, I think I've got this third one figured out. Got
How'd you work it, or what direction did you take it in?
Okay. Let's see if this makes sense. Okay. So what I did is I multiply or use the identity for the double angles, and I simplified it out. I turned that into tangent. Oh yeah, okay. So I turned it into tangent, and then I multiplied both sides by cosine to get rid of the one over here in the denominator. So I have 2 sine cosine squared equals sine of A, and then I subtracted the sine over, and then what did I do there? Oh, wait a minute. I don't know if this is valid, actually, now that I look at it again, but I said
factored out. Oh.
Oh, yeah. Oh, okay. Yeah, I got you. Yeah, this is valid. Okay. So I factored out a sign here from all of this. And so we got 2 cosine squared minus 1. And so
Okay.
I set both sides equal to 0. I solved for alpha. Here we have alpha is 0 and pi for sine.
And then you set the 2 cosine.
And then I did cosine. I added 1 to both sides. I divided it by 2. Then I took the square root, which gave me square root of 2 over 2. And then I took the inverse cosine, and that is pi over 4 and 7 pi over 4. And it's asking to find all angles in 0, 2 pi that satisfy the equation. And all of these angles are within 0 and 2 pi.
Very impressive.
Does that make sense?
Yeah, it makes sense. Kylie, I feel like it's like easy question, crazy question, easy question.
Yep.
What are you doing?
And then,
well,
were you able to solve that last one?
Yes, let me dig up. Did you plug it in with the calculator?
Yeah.
Okay. Give me 2 seconds to dig up my calculator because my son is a kleptomaniac, kind of.
Okay.
Giovanni, where's my calculator, please? Or are you just gonna sit there? Come on. You took it. I saw you take it. Okay. This is Do you get -1?
Yeah, negative square root of 6 over 2.
Oh. Most definitely not -1. Let me see. Okay, so that's so sin x, sin y plus 2 cosine. Hey, you're okay. You're okay. Giovanni. I got the decimal, but I need to see what that is in a fraction. I got -1.22 just plugging it in, but
Well, that's what square root of 6 over 2 is, or negative square root of 6 over 2.
I work backwards. Oh, yeah. There we go. I always have to check myself with the calculator because I get so messed up with all the fractions.
Yeah.
Yeah. That one wasn't. Hey, what? Stop spitting at the cat. No. Okay, well, that looks good to me.
All right.
Do you want me to submit it? I think you did it last week.
I'm okay with whatever. If you want to, that's fine.
Let me see.
But
Hey,
I'm perfectly fine submitting it.
if I could double check your third one. Giovanni, please stop. Hold on. I know. You're okay. Sorry. Okay. Fun. He's had a very trying day.
I bet.
Okay. Yeah, it's that first little bit. I just want to make sure I'm understanding how you got tangent and then you did the sine. That's smart. We were too busy looking at the tangent side. Didn't realize that we could. Different. Zero, and then you set them pi over 4. Okay, got it down. I'll go ahead and type that up and get it going, or not type it up, but
Yeah. Okay.
Awesome. Any other questions or anything else you feel like going over?
I don't have any other questions. Unless you do.
Yeah, I think I'm doing pretty good. I makes a lot more sense now. But awesome. Well, I will get this submitted.